Hello HIC students, welcome to another week of Math at Home. This is our 15th video and today we're going to be dividing our lesson into three sections. We're going to have our 6th graders learn about the formulas to find the area of quadrilaterals. We're going to have our 7th graders learn about the properties of similar figures. And our 8th graders will learn all about the properties of rotations. So let's get started. For our 6th graders, today we're gonna be learning about how to model and find the area formula for trapezoids, parallelograms, and rhombus. And we're gonna have the following problem. Let's say that you wanna build a kite and the kite is in the shape of a parallelogram. You wanna buy material in order to build your kite, and the question says how much material do you need in order for you to be able to build the kite. For us to do this, we have to know how to find the area of this shape. So let's get to work. So for us to be able to find the area of the parallelogram, we have to look at the shape that we have. And we see that the left side of our parallelogram looks like a right triangle. So if we cut that extra part and we put it on the right side, we can see that it forms a perfect rectangle. What does that mean? Well, that means that the area of the parallelogram can be found by using the formula for the area of a triangle, of a rectangle. In other words, the area of a parallelogram is going to be equal to base times height. On this problem, we are going to find the area of the following parallelogram that has a base that's equal to 13 meters and the height is equal to 9 meters. So for me, in order to do this, I just have to use my formula for the parallelogram, which is going to be base times height. So that means that I'm going to multiply the 13 meters times the 9 meters, which represents the height. So in order for me to do this, I'm gonna do the multiplication very quickly over here. 3 times 9 is gonna be 27. I carry 2. 9 times 1 is 9, plus 2 is gonna be 11. So that means that the area of the parallelogram is going to be 117. And remember, since we are multiplying both meters, then the area is going to be meters to the power of 2. In other words, my area is going to be 117 square meters. And now is your turn. You're going to find the area of the following parallelogram. The base is equal to 14 inches and the height is equal to 6 inches. You're going to have a couple of seconds in order for you to get the right answer. And now we're going to get to the shape of trapezoids. And as we can see, if we put two trapezoids together, they form a perfect parallelogram. What does that mean? Well, as we can see, the two shapes of the trapezoids are the bases are going to be one part of the big base of the parallelogram, and the other side is going to be the top one. So in order for us to be able to find the area of a single trapezoid, the only thing that we have to do is to make the formula of the parallelogram and then get half of that. So that's why the formula for a trapezoid is equal to 1/2 the height times the addition of base 1 plus base 2. In the next shape is going to be a rhombus. And as we can see, if we have this shape, we can draw two diagonals that are going to form four different right triangles. And basically what we do is if we put all of these right triangles together, they are going to form a perfect rectangle. But this rectangle, the base is going to be equal to the first diagonal, and the height will be equal to half of the second diagonal. So now we just have to multiply base times height, which will mean that the area of a rhombus is equal to half the multiplication of the first diagonal times the second diagonal. And now is your turn. You're going to find the area of the following trapezoid that has a height equal to 14 inches, base 1 is going to be equal to 15 inches, and base 2 is going to be equal to 9 inches. You're going to have a couple of seconds for you to get the correct answer. For our sixth graders today, we learn how to find the formulas to be able to calculate the areas of parallelograms. We were able to know that it's base times height. We also found the formula for the area of trapezoids, which is gonna be half the height times the sum of its two bases. And we also found the formula for the area of a rhombus, which is half the multiplication of both its diagonals. And now we're ready for our 7th grade section. For our 7th graders, today we're gonna learn about the attributes of similarity. Specifically, we're gonna be talking about ratios within and between shapes. And we're gonna start with the following exercise. It says that we have a tree that is 20 feet tall and it makes a shadow which the measurement is 5 feet. Then we have a person that's standing next to it and the shadow that the person makes is 1.5 feet wide. The question says, if both of them make a right triangle in between the shadow and its height, then what will be the height of the person standing next to the tree? In order for us to do this, we have to learn how to find missing sides using the properties of similarities. Before we can properly execute the problem of similar shapes, we are going to be talking about two key properties of similarity. The first one is that the corresponding angles of two shapes that are similar have to be congruent. And congruent just means that they have to be exactly the same measurement. And the second property of similarity is that the corresponding sides of two shapes that are similar have to be proportional. So that means that the ratios made by the two measurements are always going to be equal to each other. So, as we said, these two images, the tree and the person standing beside it, they form a right triangle between its height and the shadow that they make. And that right triangle that they make both are gonna be our similar figures. So we know that one side, the height of the tree is gonna be 20, and the shadow is gonna be equal to 5. Everything is in feet. And then we have our person, which we only know the shadow equals 1.5 feet, but we don't know the height, so I'm gonna put an X on it. So in order for us to be able to solve this problem, I'm just going to use proportions, and the proportions are going to be based on its corresponding sides. So I know that the number 20, which is the height, is corresponding to the missing side x. So I'm gonna make my fraction 20 over x, and then the next fraction is going to be our measurement of the shadow, which is 5 and 1.5. So I'm going to put it right here, 5 over 1.5. And remember, in order to make it a proportion, I just have to draw an equal sign in between these two fractions. So now that I have this, the only thing that I'm missing is for me to be able to make an equation out of these two fractions. So I'm gonna be using the butterfly method, which tells me that I'm gonna multiply 20 times 1.5. Remember, I'm gonna multiply diagonally, and that's gonna be equal to 5 and x because I'm multiplying both terms. 20 times 1.5 is gonna be equal to 30, and then that's gonna be equal to 5x, and the last step will be for me to divide 30 by 5, and then I will see that x is gonna be equal to 6. So that means that the person standing next to the tree, its height is gonna be equal to 6 feet, and that's how you use proportions to find a missing side on a similar shape problem. And now is your turn. You're gonna find the missing value of x with these two similar shapes. You're gonna have a couple of seconds to find the correct answer. And now we're gonna learn how to find the missing side of two similar shapes. But now, as you can see, they're drawn one on top of the other. They are overlapping. So the first step for our strategy to work is going to be for us to draw these two triangles separately. So I'm going to start with that orange small triangle ABC, and I'm gonna make sure that I put the side that's equal to 2 inches and the bottom is equal to the X. And then I'm gonna draw my big triangle ADE, which the bottom is equal to 8 inches, and the side is gonna be the addition of the two parts that you see there, 2 and 3. So that means that my side is gonna be 5 inches. And now I'm ready to start working on this problem. I'm going to start by making my proportion, which is going to be, remember, the corresponding sides, 5 inches over its corresponding side, which is 2 inches. And the other fraction is going to be 8 inches on top of the corresponding side, which is equal to x. And in order for me to make it a proportion, I just have to draw a equal sign in the middle. And we're gonna be solving this with the butterfly method. Remember, we multiply in diagonals, and I'm gonna make my equation 5x equals the multiplication of 8 times 2. That's gonna be 5x equals 16. And now dividing 16 by 5, I know that the missing side x is equal to 3.2 inches. And now is your turn to find the missing value of x. You have two overlapping similar triangles. You're going to have a couple of seconds to find the correct answer. For our seventh graders, today we learn the properties of similarities. We also learn how to find missing sides using proportions, and also how to find missing sides when we have two overlapping similar shapes. And now we're ready for our eighth grade section. For our eighth graders, today we're gonna be talking about the properties of rotation of two-dimensional shapes. And we're gonna start by defining the word rotation. And this is a transformation of a two-dimensional shape, and it's always moving in a circular way around a center of rotation. It always remains the same size and the same shape, but change its position. In order for us to start, we're gonna review the three types of rotations that we're gonna see today. The first one is a 90-degree clockwise rotation. And a 90-degree means that it's only going to move one quadrant, and it's gonna go the um, with the movement of the clock. So that means that my new image is going to be on quadrant number 4. The second type of rotation is going to be a 90 degrees counterclockwise rotation. And this means that it's going to move again only one quadrant, but now it's going to go against the movement of the clock. So now my new image is going to be on quadrant number 2. And the last type of rotation that we're going to have today is the 180 degrees. And that means that the shape is going to move two quadrants, meaning that it's going to be on the opposite side of where the image is standing. In this case, the image is going to be on quadrant number 3. And to start our lesson, I want to start with rotating a single point. And this point right here is on the coordinate -1 and +3. And now, as you can see, we're going to rotate it 90 degrees clockwise, which we said it means that it's going to move only one quadrant, moving with the clock. So now the coordinate on the y's, which is equal to 3, is going to move to the coordinates on the x-axis on the right side of it. So that means that now it's going to be the x is going to be equal to +3, and the -1 is now moving to the coordinates of the y's. So that means that now we have a coordinate of +1 on our y's. And that means that my new point is going to be on +3 and +1. Let's look now at a 90 degrees counterclockwise rotation. And that's going to be the same way, but now we see that it's moving counter to the clock movement, and now is on quadrant number 3. And its new coordinates is -3 and -1. And if we have the last one, which is the 180 degrees, we see that is in the opposite side of the point, which is
positive 1 on the x's and negative 3 on the y's. And now we're gonna rotate a whole figure. And on this one we have a trapezoid that has 4 points. The coordinates for A is positive 2 and positive 2. Coordinates for B is positive 3 and positive 2. Coordinates for C is positive 1 and 0. And the coordinate for D is positive 4 and 0. And now we're going to rotate it 90 degrees clockwise. And now, as we said, as you could see on the last image, what we're going to do is we're going to move these points from one quadrant to the other following the clock movement. So now the new point on A is going to be positive 2 and negative 2. So now we're going to have it right here. For B, as you can see, we are changing the position of the numbers, and the only number that changes its sign is the y's. So now we're gonna have positive 2 and negative 3. So B is gonna be right here. Then C, as you can see here, is going to change its numbers, but the y is the only one that changes sign. So now we have 0 and negative 1, and then the D is 0 and negative 4. And as you can see, now we have our new image rotated 90 degrees clockwise.
And now we are going to rotate the following triangle 90 degrees counterclockwise. And in order for me to do this, I have to remember that counterclockwise means that the figure now is going to go this way. So we're going to change from the quadrant number 2. Now we're going to go to quadrant number 3. That's where the figure is going to land. So now let's start with point A right here. The coordinates is negative 3 and 4, and this is gonna be changing to our new point, which is gonna be on negative 4 and negative 3. Notice that on the coordinates, I'm changing the number's position, and the only one that I'm messing with its sign is the number over here on the new axis. So now I know that my new point is gonna be right here, and that's gonna be the new A. So I'm gonna do the same for B. B's coordinate is negative 2 and 1, so that means that the new image is going to be negative 1, and the negative 2 we keep it. So now it's going to be negative 1 and negative 2. So my new point is going to be in here, and this is the new B. And now we're going to do the last one, which is C. Negative 4 and 1 is going to change to negative 1 and negative 4, and that's going to be right here. And now we can see that the new image is gonna be rotated again 90 degrees counterclockwise, and that's how we do a rotation on a coordinate plane.
And now is your turn. We have the point M, negative 5 and positive 3, and we want to know what is the coordinate of the point if it's rotated 90 degrees clockwise. You're going to have a couple of minutes in order to find the correct answer. And now we're going to do the last rotation, which is a 180 degrees rotation. And as we said at the beginning, a 180 means that the numbers are going to change to its opposite signs. So we have the following triangle ABC. The A coordinate is -3 and +4, and now it's going to change to +3 and -4. So that means that the point is going to go right here. For B, it goes from -2 and +1 to +2 and -1. So it's going to go to the other side. And now C, from -4 and 1, you can already see the pattern. Now it's going to be +4 and -1. So it's going to be right here. And as you can see, now we have this triangle rotated 180 degrees. And now is your turn. You have the following rectangle that is on quadrant number 1. And if the figure rotates 180 degrees, in which quadrant will it appear? You have a couple of seconds to choose the right answer.
For our 8th graders, today we learn about the properties of rotation. We learn how to rotate a single point and also how to rotate a whole image. And that's the end of our lesson for today. Thank you so much for watching another video of Math at Home. Remember to visit HISD at Home for more resources in case that you need them. Make sure to follow me on Twitter and Instagram in order to get these videos for you to watch at your earliest convenience. Have a nice week, and I'll see you on the next Math at Home.